hey. Alex Bryant. Get to the office. Alright, hi, it's Mr. Nelson. This is lesson 8.1. We're comparing additive and multiplicative relationships. The TEKA is 6.4a. We're comparing two rules verbally, numerically, graphically, and symbolically in the form of y equals ax or y equals x plus a in order to differentiate between additive and multiplicative relationships. Alright. What this basically means, for all intent and purposes, is that when you compare verbally, it just means when you come up with a rule, you're going to talk about it. Numerically means write a numerical expression. Graphically, graph it, and symbolically is put it into a table. So let's talk about the differences between an additive and a multiplicative relationship. Okay, so when we talk about an additive relationship, that would be like the relationship between, let's see, my brother and my own age. That's an additive relationship, meaning that no matter how old my brother is, if you add 7 years to it, that's my age. So the rule, and it says you have to express the rule verbally and numerically. The rule would be, to find my age, you would add 7 years to my brother's age. That's the rule. And so we're going to put that into a table. We'll graph it. But that's basically an additive relationship when the rule is you can add from one thing to another to find the relationship. Alright, multiplicative, on the other hand, it's pronounced multiplicative, means that it's when you have to multiply. So an example would be, an example of a rule for a multiplicative relationship would be, if burgers cost $3, the rule would be you would multiply the number of burgers by 3 to find the cost. If burgers cost $3. So for example, 5 burgers times $3 each equals $15. That's an example of a multiplicative relationship. So that's what we're going to be looking at. We're going to compare additive and multiplicative relationships in this video. Alright, so Kai is 7 years older than his sister Lou. Graph the relationship between Kai's age and Lou's age. Is a relationship additive or multiplicative? Explain. Okay, so Kai is always 7 years older. So my advice to you guys when you have a table like this is to make a third column. I'm just going to extend this out like this. And write the rule in here. So this is, I'm adding 7. So I'm going to say 1 plus 7. If Lou is 2 years old, I add 7. If Lou is 3, I add 7 to find Kai's age. Add 7. This is an additive relationship because I'm just adding each time. So Kai would be 8 here, Kai would be 9, Kai would be 10, Kai would be 11, and Kai would be 12. Okay, so that is an additive relationship. Additive. Alright, over here we have a coordinate plane. And a coordinate plane is made up of a horizontal axis and a vertical axis. The horizontal axis is going to be Lou's age, and the vertical axis is going to be Kai's age. And where the horizontal and vertical axis meet, we say that that is the origin, and that represents 0 right here. This is the origin. That's why it's labeled as O. The vertical axis we can also label as the y-axis or the output axis. The horizontal axis here we can label as the x-axis or the input axis. We put stuff into it, and then out comes the y-axis. Okay, so
Anthony Jackson, come to the.
So in this case, when we're graphing, when Lou is 1, so you have to pay attention to the numbers. This is 1 right here for Lou. When Lou is 1, Kai is 8. So I'm going to come up here to 8 for Kai, and I'm going to put a little dot. All right, when Lou is 2, Kai is 9. When Lou is 3, Kai is 10. When Lou is 4, Kai is 11. And when Lou is 5, Kai is 12. Now look how it's evenly spaced, the dots are. Look how they go in a straight line right here. Look how there's no gaps between them. And look how it doesn't increase by much. It increases by 1 each time. So increase by 1, increase by 1, increase by 1. This is what an additive graph would look like. That's what an additive graph looks like. Okay. So here, if we're going to write the rule for this is that to find Kai's age, add 7 to Lou's age. And that's exactly what the TEK is asking us to do, is to show it in symbolically right here, show it graphically right here, show it numerically right here, that's a numerical, and show it verbally, which is right here. Alright, here's another example. Internet cafe charges 10 cents for each page printed. Graph the relationship between the number of pages printed and the printing charge. Is the relationship additive or multiplicative? Explain. Okay. So let's start by constructing a table. What two things are we comparing? We're comparing, I guess you would say we're comparing pages to money. So if we're going to make our little table over here, we would say, okay, I've got pages right here, and right here I'm going to put the rule, and then right here I'm going to put the cost, how much it costs per page. Okay, so let's say we print one page. Well, the rule is 10 cents per page. So I say one page times 10 cents, and that's going to come out to 10 cents. No problem. All right, well, what happens if we buy 2 pages? Well, the rule is 2 times 10 cents, which comes out to 20 cents per page, or 20 cents total. All right, so let's say 3. All right, here's the rule. 3 times 10 cents, 3 pages times 10 cents a page comes out to 30 cents. And let's do one more here. Alright, 4 pages. The rule is 4 pages times, and it's 10 cents a page. That's going to come out to 40 cents. Alright, so I've set this up graphically. Well, not graphically, but symbolically. This is the symbolic part. Here's the mathematical rule right here. Now, if I do it verbally, the rule is to find cost of printing. There we go. Multiply the pages by $10 cents. That's our rule. So now we've done that verbally. Now we just have to graph, okay? So that's not very hard. We come over here. 1 page is 10 cents. All right. It says 2 pages is 20 cents. So 2 is 20. 3 pages is 30. So 3 is 30. 4 pages is 40 cents. Okay, so if I had to guess what 5 pages would be, it looks like I go over 1 and up 2, over 1, up 2, over 1, up 2, over 1, up 2. I bet if I had to guess that if I printed 5 pages here, it would be 50 cents. Notice the difference in height. In the previous example, we're going up by 1. In this example, we're going up by 2 each time. This is an example of a multiplicative relationship. It's multiplicative. Okay? And that's all. So copy down what you see on notebook paper. Use it to answer the questions on the Google Doc. You should get all the questions right. And I'll see you in class on Monday. Have a great weekend. Bye.